Mihir Shah once again with another video. In this video, we're going to learn how to solve problem sum based on simplex method under the topic LPP, or also known as linear programming problem, under the subject operation research. Again, a very important topic for all the STEM 6 students of TYBMS. We are going to take up one problem sum whereby we'll be learning the basic formulas and the tabulation, okay, how it has to be done, and using that any other sums also you can replicate the same method to solve any other sum. Okay, so chalo, let us see how to solve problem sum based on simplex method.
Okay, now in order to solve the sum based on simplex method, okay, this is the question. Maximize z is equal to 50x1 plus 20x2 subject to constraint. They're giving you two equations and then they're giving you non-negativity equations. Okay, now the very first step, okay, remember under simplex method will be that you have to convert the constraint and maximize z value use with something called as a slack value. Okay, those are basically nothing but unutilized capacity values that we're going to write. Okay, so what we're going to do here is the constraint which were given, okay, the constraint which are given, we are going to add some slack values to that. So basically our equation will become 20x1 plus 10x2 plus s1. We're going to add here s1, which is equal to 500, and our second equation will become 50x1 plus 50x2 plus s2, which is equal to 300. Okay, and our max z will become 50x1 plus 20x2 plus s1 plus s2. Okay, so first step, we need to add something called as a slack value. This is unutilized value or dummy value, you can say in that case. Okay, now once we have done that, now we'll have to create a simplex table. Okay, now this is very important. The construction of the table is very important. So chalo, let us see how we can create it. We will utilize this whole thing. So I need 1 2 3. That's like my 1 2 3 4, and one more after that I need 5. Like I need like 5 columns. I have something called as replacement ratio on the last. I will have the value of Cj, something called some new terms are there in this. I'll need one more column after this. And here I will need, we have x1 x2 s1 s2, so I need 4 columns here, 1 2 3 and 4. Okay, so remember this is known as my simplex table. So I write here simplex table. Okay, now let us see the headings. Okay, what headings we'll have to give them. This is something called as Cj. This is my ratio or replacement ratio, also known as. This will be called as C. This is my x. This is the value of b. I'll have x1 x2 s1 s2. These are my constraints. Okay, I'll need zj, and then I'll need the change, which is cj minus zj. Okay, under x I will write the slack value s1 and s2. So this is a basic start of a simplex table. Always remember the C value at the start will always be 0. So both the values will be 0. Okay, now let us see how you can fill this, how we'll have to fill this. CJ stands for the maximization constraint. X1 is 50, X2 is 20, S1 is not given, so 0, S2 is not given, so 0. That is step number 1. Step number 2, now this is like our first constraint. Okay, S1 will be, S1 is in the first constraint. B stands for the total value which they are giving you, so that's 500. X1 ka value is 20, X2 is 10, S1 is there present here, so that we'll consider that as 1. S2 is not there in that equation, so we keep it as 0. Okay, same way for S2, that is the second constraint. The total is 300. This is 50, this is 50. S1 is not present in this, S2 is present, so we write it as 1. Okay, that is the thing what we need to know. Now how to get the Zj. So remember this formula. Zj is nothing but the value of your C column. Okay, so it is basically C column multiply by value of each variables, like in your constraint which were there. So I'll write here C column multiply by each variable column. Okay, now what I'll do is I'll pick an additional paper where we will be basically doing the working. Okay, so now in order to find Zj for x1, for this, these are my columns. Okay, so for x1 the formula is C column. Okay, C column ka value, that is 0, into the value of each variable. So it is C into this and then plus this into this. Okay, so it will be C into 20 plus the next C ka value is also 0, so 0 into 50, which comes to 0. So my first Zj will be 0. For x2 it will be 0 into 10 plus 0 into 50, so again it comes to 0. For S1 it will be again 0 into 1 plus 0 into 0, which comes to 0. For S2 it will be 0 into 0 plus 0 into 1, which comes to 0. Now remember, in the simplex table number 1, this is my first simplex table. In first simplex table, just remember Zj will always be 0. Okay, because when you multiply, because starting values are 0, so it will all be 0 only by default. Okay, chalo. So once we have done that, okay, once we have got those values, we'll go ahead now with the sum. Now we need to find the change. Change is nothing but already given, that is Cj minus Zj. So 50 minus 0 is 50, 20 minus 0 is 20, 0 minus 0, 0 minus 0. Okay, so we are able to create the first part of it. Now from here you have to be very careful. Okay, now we need to find something called as key column and key row. Okay, two things we need to find: key row and key column. Okay, so now remember, we need these couple of things. I need you to find key column, we'll need key row, and we'll need the key element. Okay, now in order to find the key column in Cj, in the change, the last Cj minus Zj, check which is the highest value. So 50 is the highest value. If 50 is the highest, we will mark this particular, we'll draw a box over this particular row. Okay, so my key column, that is the highest in the change, that is x1. So my key column is x1. Okay, now in order to find key row, okay, in order to find the value of key row, because there can be two rows, s1 and s2, there are two rows are given, so we'll have to select that. In order to find the key row, we'll have to find something called as the ratio. Okay, so how to find the value of ratio? Okay, I would show you here, but I can show you here itself now. The rule is, the ratio ka rule is, its formula is basically b divided by the key column. So in our case it will be 500 divided by 20, which comes to 25, and 300 divided by 50, which comes to 6. Okay, so your key row, now from these two you have to find the key row is always the lowest in the ratio. So among the two, which is the lowest? 6 is the lowest value. Lowest value stands for S2, so my key row is S2. Okay, so what we'll do here is, now we need to mark this. We'll be marking it out. So this whole thing, get marked out. So the intersection of row and column is nothing but a key element. So a key element ka value, I'll just put a dot here, is 50. Okay, so this is your step number 1 that you need to solve, you need to do while solving the sum based on simplex method. Okay, now what happened here is, once we get a key column, okay, now, and your key row, so what will happen here is, the key column was x1 and key row was s2. Now your s2 will get replaced by the value which was in your key column. So your key row gets replaced by key column. Okay, so now we will start preparing the second table. I'll note down this as simplex table 2. Same table. Okay, we'll prepare the same column, same table. So chalo, let us create that first. So I'll need 1, 2, 3, 4, 5, 6 columns again. So that's 1, 2, 3, 4, 5, and 6. Okay, here I will have b ka value, I'll have the value of x, and I'll have the value of c. I need ratio ka one last column will be ratio, and I need 4 variables. So 1, 2, 3, and 4. Okay, I'll note down the headings. So our headings will be similar. Cj, this is my ratio. I'll have c, x, and b. This will be my zj. This is the change, which is cj minus zj. Okay, now whatever was your we'll have to now. So now cj ka values were 50, 20, 0, 0. Okay, now in order to get the value, okay, now so cj I have noted down as it is. Now the rule is, now look at this very careful. X1 and S2 are selected, so X1 will replace S2. So S1 is as it is. I will write S1 as it is. Now S2 get replaced by X1. So we put X1 there. Now X1 ka value was 50. So the S1 is 0. X1 ka value was 50. So we put the 50 value here. Okay, x1 ka value was 50, so we did put it here. Now this is x1, this is x2, s1, s2 as it is. Okay, so we have done those parts in that case. Now let us see how to go ahead with the sum. Okay, now in order to fill these values, so first thing what you need to do is, we need to find, number 1, we need to find new values for key row, because it was S2, now it's been changed to X1. My key row was S2, so now S2 got replaced by X1, so we'll have to find the new values, and the formula is a old value, that is of S2, divided by key element. Okay, so now look at this. Okay, look at this. I'll again get the working. Okay, we'll get the working part here on the another sheet. So this was the first working that we had done. Now in order to find the new value, the formula is, so I'll write a new value. To find the very first new value, the old value was 300, so it will be 300 divided by the key element, which is 50. So I'll write here 300 divided by 50, which came to 6. So I'll write this value as 6. Next, x1 mein the value was 50, so it was 50 divided by 50, which is 1. x2 mein again it was 50, so 50 divided by 50, it is 1. 0, so it was 0, so 0 divided by 50, it is 0. And last mate was 1 divided by 50, so I'll keep it as fraction only. 1 divided by 50, I'll keep it as 1 divided by 50. Do not make it in point. Fraction will be a better choice here. Okay, so this is 1 divided by 50. Okay, so that is how we have found the values for the key row. Now we need to find the non-key row. Okay, basically the other row. So now we need to find new values for non-key row. The formula is old value minus corresponding key column into new value of key row. Now the formula looks this is big, but while solving it is very simple. Okay, so let's see how we will find this new value. Okay, so we'll write it a new value. Now for the first one, okay, now this is basically for S1 column. Now old value, B ka old value was 500, so it will be 500 minus corresponding is given here, corresponding key column. Now key column is x1, so corresponding key column was 20. Okay, so in this entire line the corresponding key column ka value was 20, so it will be 20 multiplied by the new value of key row. So the new value of key the key row is 6, so I get this as 500 minus 20 into 6 is 120, so the value comes to 380. So I'll write this here as 380. Same way for x1. Okay, for x1 the old value was 20 minus the key column ka value is 20 into the new row value is 1, so 20 minus 20 is 0. For x2 the old value was 10, so 10 minus again it will be 20 into the new value is 1, so it will be negative 10. So I write this as negative 10. For the fourth one, the old value was 1 minus 20 into 0, so we'll get this as 20 into 0 is 0, so we'll get this answer as 1. And same way for lastly, old value was 0 minus 20 into the new key chain, that is 1 upon 5, 1 upon 50. So when you solve this, you'll get this value as negative 2 upon 5. Negative 2 upon 5. Okay. So 380, 0, negative 10, 1 and negative 2.5 is the new value. Okay, chalo. Once we have done that, once we got these values, chalo, we start with the zj के लिए the rule is very simple. It was c का column multiplied by each variable in the columns. Okay, so let us see how to get that value now. So for finding zj, okay, now we are first finding it for x1. So for x1 it would be 0 multiplied by, so it would be 0 into 0 plus 50 into 1, 0 into 0 plus 50 into 1. So I'll get the value as 50. So my first value is 50. For x2 it would be 0 into negative 10 plus 50 into 1, which will again be 50. For S1 it would be 0 into 1 plus 50 into 0, which comes to 0. And for S2 it would have been 0 into negative 2 upon 5 plus 50 into 1 upon 50. So 50 get cut, so answer will be 1. Okay, once I have got those value, now I can easily find the last change, so that is cj minus zj. So 50 minus 50 is 0, 20 minus 50 is negative 30, 0 minus 0 is 0, 0 minus 1 is negative 1. Okay, now this is your main key point. Okay, whether you need to go ahead with the sum or the sum gets over here itself. The moment this rule, I'll just note down that rule here. Since the chain contains 0 and negative value, that is, there is no positive value, meaning your last line, everything has to be either 0 or negative. If it becomes positive, then you'll have to solve the sum further. If all the values are 0 or negative, then therefore I can say then it is an optimal solution. What if any value would, if you would have got a positive value, then again the same steps would have been repeated. Okay, you would repeat the same step where you would have first find the key column, key row, key element in the second table. Okay, then we'll again do the marking with the ratios. We'll get the new key element, then we'll again make a new table. So we'll have simplex table number 3, same procedure, new value, and again the value you have to check whether you're getting negative or positive. If it is positive, again it repeats. If negative, the sum gets over there itself. Okay, so since it is an optimal solution, my final answer will be, they wanted max z is 50x1 plus 20x2. Here only x1. So in this case we didn't have any ratio. Okay, the ratio part was not there. The sum gets over there. So here x1 ka value, we'll have to take x1. Okay, so x1 ka value was 6. S1 is not there because this is 0. So 0 I can't take. So only for 50, that is for x1 it is 6. For x2 there is no x2 been selected here. So it will be 50 into 6 plus 20 into 0. So 50 into 6 is, which is 300. So my max value is 300. So my optimal solution is 300. Okay, so this is how you all had to solve the sum based on simplex method under LPP. Okay, so I hope everyone have understood that. With that, we will be ending this video here. Thank you.